Thank you so much for the great conference, Cyril, and the other organizers of this wonderful conference. I learned so much, and it is even better than the real face-to-face. Anyway, so Cyril, you're doing a great job. Really thank you, and everybody else in the organizing committee. Before starting this talk, it's appropriate and fair to issue a warning. This is not a proper math talk because it's part of CIRM, C-E-R-M. The M, I guess, stands for Mathématiques, which means in English mathematics. So it's supposed to be a real proper math talk. But I have to disappoint you for those who expect a proper math talk because it's not a proper math talk, and because Kimmo Eriksson, who was mentioned in the last talk, once gave a talk to his department, and the dean, after the talk, reprimanded him. Kimmo, this was not a proper math talk. Most of the people could understand most of it. So this is really not. So my talk will not be proper because it will be understandable, which is appropriate to the last talk of the conference. Anyway, before going on to my own talk, let me comment. Initially, well, Cyril asked me about my preference of scheduling. I said, I want to be as the first day because then I can enforce the so-called Zeilberger reciprocity theorem. If you don't come to my talk, I won't come to your talk. But then he twisted my arm to move it to the last day. So now I kick myself because in Monday morning, I set the alarm at 3:50, so I will not miss Mireille Busquemelou's talk. And as far as I could see, 5 minutes ago, she was not here. Miss Mireille, are you here? Okay, so you tricked me, Cyril. Anyway, and maybe that's as well because I'm going to mention Mireille later on. So first, let me tell you about the competing. Aline and other people mentioned the guest and check, but he didn't mention that in the current incarnation to Lattice pass, it's really started, I believe, although some manifestation of it came before, with myself and my close collaborators, Manuel Carlos and Christoph Kutschan. So let me just comment first on Mireille's, too bad she's not here. Shame on you, Mireille, for playing hooky. She gave a beautiful but sophisticated, fancy approach to the 3/4 plane Crevaras walk. For those who missed Mireille's talk and other talks, let me remind you, it's very easy to enumerate walks in the plane that only have the step right and up. But if you also, even in the quarter plane, but if you also add the step southwest going down, then it becomes much harder. And it took Germain Crevaras about 45 pages to prove his amazing result, a beautiful closed form for the number of ways of walking using 3 end steps from the origin back to the origin using these 3 fundamental steps. And it was surprisingly hard to prove. And even subsequent shorter proofs by Mireille Busquemelou, Ira Gessel, and a few other people were not really simple. And what Mireille was talking about in the first talk of this conference, that I set my alarm for 3:50 to attend, and I'm very disappointed that Mireille did not show up or even write me email to apologize. Anyway, that she gave a much more difficult problem, even more difficult, to walk in the 3/4 plane. So you can walk everywhere except in the 4th quadrant. Then there's no longer a nice formula for going back to the origin. but you can, using numeric dynamical programming, crank out the first 50 terms, that suffices, and get a nice third order, very complicated recurrence. But from the eyes, in the eyes of God, a third order recurrence, even a 10th order recurrence, is not as good as the so-called closed form. Only stupid humans think that closed form is so good. What is closed form? Is that the solution of a first order recurrence? So it takes the memory allocation is 10 times as much, but big deal. So in the eyes of God, the solution, the recurrence for going back to the origin for the much more difficult case of 3/4 of a plane is almost as simple. But what about proving it? So 12 years ago, my good collaborator, Manuel Carros, came up with a one-line proof. And here is a one-line proof. Manuel, can you unmute yourself and explain how you got it?
Oh, yeah. So this is a guessed operator. So it's guessed by the first sufficiently many terms, and then it was proved by commutators.
So it's really a routine once you have it. And how did you get it? By guessing and checking. First you have to crank out using numeric dynamical programming. You crank out the first 1,000 data points or whatever. You keep trying, and you keep upping the suspected order of the recurrence and the suspected degree of the coefficients, and sooner or later, and the computer doesn't mind. Computer is very patient. And what results is this, and to prove it rigorously, is that a computer does it in 5 seconds. To find it, it took, Emmanuel, how long did it take on your computer to actually find this beautiful?
No, I don't remember, but I think it was 10 years ago. It was a hard problem. Maybe now it's not so hard.
Okay, so 10 years ago, it took maybe a few hours or even more. But by now, it will be, anyway. But once you have it, this is purely routine. So that's a one-line proof of Guevara's theorem. Once you have it. Now, it's based, the idea was in this masterpiece that I wrote with Manuel 12 or 13 years ago. So the motivation was at the time, the big open problem in lattice path enumeration, the Ira-Gessel intriguing conjecture. Ira, are you here? Oh, Ira, say something. Unmute yourself and say, yes, sir, I'm here. Ira, once again, violated the Zeilberger reciprocity. I came to you talk, and okay, I won't come to your next talk. Anyway, I forgive you because you made this beautiful conjecture. At the time, it was wide open, and then Manuel, together with Christoph, we find the first proof of the Gessel using the same methodology, the guess and check. And then, so it was even harder, but it was a big challenge. So we gave the first proof. Then later on, so in this paper, we offered, or rather I offered, a reward for a human-generated proof without using computers. And Mireille almost achieved it. At the end, she had to cheat and did some much shorter computer calculation. But still, it was almost human, but not quite. But I gave her the prize. But what I didn't like was the title of her paper, an elementary proof of Gessel's conjecture. Our proof is as elementary as can be. Her techniques are fancy, non-elementary, using the kernel method and all this highbrow stuff. So it's a nice proof. I'm not saying it's not nice, but it's not elementary. Our proof is much more elementary. Anyway, this is my tirade about the title. And moving right along, Murad, are you here? Murad, say something. Oh, well. during the talk, beautiful talk of Murat, he mentioned, unrelated to the topic of his talk, he mentioned a certain conjecture of a colleague called Brennan. And shame on me, and George Andrews would have immediately recognized it, but if he would have been there, but Christian Kaisenthaler noticed that the conjecture, the expression of Brennan was exactly the famous Mcmahon box theorem mentioned by George an hour ago. So thanks to Mcmahon, we know, of course, that it's a polynomial, and not only that, with positive coefficients. And here is a golden audio of mine that uses the Lewis Carroll method to prove the Mcmahon. This is the Q equals 1 case, but the same techniques. So using the Lewis Carroll identity, but this is just in the size. Moving right along, I want to comment on Philippe's beautiful, beautiful talk, very, very colorful, with an intriguing conjecture, a certain explicit determinant expression. So using this approach that I initiated in 2007, that really uses human ingenuity. It's basically trying to reverse engineer, using George Andrews' expression, the human ingenuity of George Andrews, and in an equivalent form, logically, of Dave Robbins, to evaluate determinants featuring binomial coefficients. So it's really trying to guess and check in a human way. But in this paper, I don't have much time to go over it, but you're welcome to go to my homepage. I call it the holonomic ansatz, how to automatically discover and prove holonomic determinant evaluation. So it's basically teaching the computer the techniques of George Andrews and Dave Robbins. And once you have it, it's a one line. You just have a command. There is a entry of the matrix, and lo and behold, it gives you a fully rigorous human readable proof. So at the time, we can do lots of determinants, including one that Herb Wilf had to work pretty hard in, and of Dave Robbins, but we could not yet do the Holy Grail at the time. Soichi Okada, are you here, Soichi? I'm used to say, yes, sir, I'm here. Soichi?
I'm here.
Oh, hi. So he gave
Can
an
you hear me?
amazing, he did most of the work. The enumeration of so-called TSPP, totally symmetric plane partitions. The Q enumeration. Q equals 1 was done by our beloved George Andrews, but the Q analog, the full Q, was wide open. It was conjecture due to independently to George Andrews and to Robbins, Mills, and Ramsey. Anyway, using this methodology, the Q analog of it, Christoph Kutschan, Manuel Carros, and myself proved it completely and gave the first, and so far I think the only, proof of the QTSP conjecture. So, but once again, it was elementary. But now I was wondering whether the same technique can be done to tackle Philippe's beautiful. So Philippe gave two beautiful formulas for some interesting quantity, the 20 vertex, blah, blah, blah. In the square eyes model, famously done by Elliott Leib, was extended beautifully in Philippe's talk to 20 vertex. And then he had some quantity. You're welcome to look at his paper and slides. And he gave two beautiful expressions. One of them was closed form, constant term expression, a little bit reminiscent of the constant term that I had way back in the ASM conjecture. And he gave a nice, beautiful looking determinant. And I wrote email to Christoph Kutschan, who is not a participant here, but he should have been. And sure enough, he proved it. And here is the email method in one day. So tell you how powerful this method is in the hands of. And by the way, recently, Christoph, together with Elaine Wong, my former student, Ek Tota Sapon, Tanatipanonda, and Mr. Du, put in the archive other very challenging determinants that Christian Kasenthaler couldn't do way back. So this apparently was a little bit easier because it took Christoph only a few hours to do it. So let me. I need. My voice is getting tired, and I'm getting so I need a volunteer. And Elaine Wong, are you here, Elaine Wong? Please unmute yourself and say I'm here, Elaine Wong.
She's typing in the chat, but she says she can't speak on the microphone.
Okay, she cannot speak. I want somebody else to read it to me. Shaoshi, are you here? Shaoshi Chen?
Doron, we can win some time. So in the chat, there is Christian, Doron, Hélène, Elena, Eric, Florian, George, Anna, Hans, Helmut, Ilse, and so on and so on. You want me to go on the list?
Okay, any volunteers to read it, this message?
No.
Okay, Cyril, you read it.
The message? Oh, for Hélène. Okay. Dear Doron, thanks for your message and nice challenge. It is the one by Christoph. Okay. Dear Doron, thanks for your message and nice challenge. Actually, I have seen this determinant before. Christian Kasenthaler pointed me to it, and some variations and generalization of it. After we had sent our masterpiece on binomial determinants. Indeed, this kind of determinants are probable by the you move it difficult by the holonomic ansatz. For the one you sent me, the following happens. Guessing is
okay.
easy.
Thank you, Cyril. Okay, basically, the step in my paper for 2007 gave you these 3 steps of doing it. So it tells exactly the times. Thank you, Cyril. For each 15 minutes to do step 1 and 25 minutes to do step 2. And yeah, so altogether it's less than an hour, and we have a full rigorous proof of the different Sesko conjecture, and hopefully they write it up and post it. So this is the triumph of the guess and check method. That's completely elementary. So no offense to the sophisticated approaches of Mireille et al. With the kernel method that I have to admit I don't like so much because I don't really understand it well because I'm a simple person. But by the way, I really enjoyed the beautiful puzzles. So I want to only do a few of them. So the first one, the Catalan numbers, is in Stanley's book, and it's a Catalan numbers in Catalan. So this I could do right away. 1, 2, 3, 4, 5, 6. And the other one was the not so smart person from Warsaw, Simple Paul. This is
Don't spoil
Mark Katz. In Mark Katz's biography.
You spoiled
in Mark Katz's biography, if I remember, he was in the oral exam of a PhD candidate, and the answer was the Simple Paul. So I gave him a hint. Look at me, I'm not very sophisticated. So who am I? So Simple Paul. Of course, Mark Katz was not so simple. But anyway, too bad Mireille is not here. I want to use this opportunity to congratulate. I was really very, very happy when I Googled a few weeks ago Mireille Bousquet-Melou. The first thing that comes out that she was elected to the very, very prestigious Académie des Sciences of the France. This is a real honor, not only to Mireille, but the implicit honors is for her advisor, Xavier. Xavier, are you here? Xavier Vienno.
Yes.
So congratulations. See, you really should be proud.
Can you hear?
That,
Yeah.
she continues your work, and it's really, really combinatorics in the hands of the pioneer, Marcos de Berger, Philippe Flageolet, my good man and collaborator, Dominique Fata, and my good friend, unfortunately not yet collaborator, Xavier Vienno, who made combinatorics socially respectable. So in the old days, some of them made it to the very snally French Academy, but only in the inferior quote-unquote category of mechanics, which is part of computer science. So both Flageolet and Zeilberger were in the computer science, which was called mechanics. So what's really impressive that Mireille is in the mathematics, pure math section. So congratulations. So now that I'm becoming an old man, speaking an old man, let me advertise in about a month from now, there's another online virtual conference celebrating a year late the joint birthday of myself, who was 70 a year ago, so be 71 now, and my good friend and collaborator Amitai Regev, who was 80 and still be almost 80. So just Google Zeilberger Regev conference. Everybody is welcome. The registration is free, so everybody is welcome. Will be some great talk by, among other, Manuel Kauers, Christoph Kutschan, Shaoshi Chen, and some other very good talks. Everybody is welcome. It's only 2.5 hours a day for 4 days to accommodate the time. So nobody will have to set up the alarm, except possibly in China. Anyway, so now that I'm an old man, I can indulge in an old man's favorite pastime, memory lane, reminiscence. So it's like yesterday, we're in the formal power series in algebraic combinatorics 1991, and let me now stop sharing. And go back to the conference. Hi, can you see me? Okay. So this is the proceedings of this amazing conference, where I met. That was really very, very, very interesting. Of course, I met Xavier and Pierre Leroux and the other mafia already in '85 in the famous Montreal 1, 2, 3, 4 conference that Pierre Leroux, who unfortunately is not here anymore, and Gilbert Labelle organized. But this conference was really historic. First was before great inflation. There were only 5 invited speakers, and it was really myself, Philippe Flageolet, who unfortunately is not here, Gaston Gonnet, who is alive and well, and Gilbert Labelle, and Pierre Cartier. So it was really amazing the beginning, and it's also in large part due to, if you know, and the others, the joining of 2 extremes. Cartier representing the Bourbaki tradition. He was part of Bourbaki, and Gaston Gonnet was really a software engineer. So, and in the middle was Flageolet. So it was really a great meeting. And for example, also the proceeding has a famous conjecture of Julian West, who gave a great talk about so-called 2-stack sortable things that I proved a month later using the guess and check. One of the first examples of guess and check in the so-called social Berger ansatz, algebraic things. Once again, you let the computer crank out lots and lots of data, guess a complicated algebraic equation, and then once you have it, it takes a few seconds to actually prove it. To find the conjecture, and later on it was simplified by Miriam Tremelou, and but still computer assisted, even computer generated. Anyway, there was the historic conference. But right after this conference was another minor conference, and part of it, the highlight, was a defense by a rising star, the second woman to ever be first prize in the so-called aggregation competition, which is a famous competition. It's a little bit like the Patnam. So she was already a prodigy then, and then here is her PhD thesis that is falling apart because I used it so much. It was really, so I was happy, I was fortunate to be in the defense with public defense. And in France, it's even more solemn occasion than here. Everybody was very, very serious. They take it very, very seriously. And Mireille gave a beautiful defense. And of course, it was all in French. And even though I could kind of follow the mathematics, the formulas, I could not follow any of the words. All of a sudden, she mentioned Sloan. So some sequence came up in Sloan. And at the time, they didn't have the OIS. It was only the first edition, the handbook. So all of a sudden, Sloan. So I found it is cute and amusing that somebody out of the blue can mention Sloan. So I laughed and said, haha. But then I get some dirty looks for other people. So I stopped laughing. So after the defense was over and she got her PhD, I went to her, introduced myself, congratulated her, and they said, oh, you're the one who laughed during my defense. So that's how she remembered. So she went on the fast track, and 5 years later, she was candidate for the so-called habilitation to make her eligible to advise PhD students. And she had a beautiful habilitation, and she suggested me as a rapporteur externe, as an external reviewer. So I agreed. So I wrote her a glowing report, and let me share it with you. So I hope I'll be able to. Cyril, do you see it? The screen? Oops. No,
you have to click on share the screen again to wait a few seconds. It will pop up. Yes, it is starting. I see the process starting.
You screen now? We don't see a screen.
In 2 seconds, we see it now.
It's loading. It will come. It's coming.
But how to make it big? Oh. Hey, how do I get to make it big? Oh. Oops.
I think if you just do full screen, it will be big. Oh, you stopped the share screen apparently.
Okay. Okay, I do it again. You do see a screen?
No, could you please share the screen again?
He's doing it. He's doing it.
Okay, it's coming. It's coming. Oh no, it stopped again.
Okay, again. Sorry.
No problem.
Do you see a screen?
It will come, yes.
Okay.
Not yet, but let's just wait.
Johan, always wait 2-3 seconds when he's asking. This is the time that it needs to come. Well, here I can say that no, we don't see it. 3 seconds are passed.
Okay, it's too bad I left. You see it now? Do you see a screen?
So no, I don't think.
Not yet, but let's wait.
Okay, sorry about that. Anyway, it was a glowing report, and you don't see a screen yet?
No.
Okay. I try again.
Did you click on share screen on the bottom?
Yes, I did, but I'll try again. Sorry about that. Okay.
Can you do it again, maybe?
Yeah, he's trying. So meanwhile, if there is some questions in advance in the room, or comments or feedback.
Okay, let me start over.
So everybody is welcome to connect with a second laptop with all the names of people that Doron knows. Like this, they will be connected and Doron won't be upset.
Okay. Thank you.
Note that the organizers have a perfect score for the reciprocity theorems of all the speakers.
Nice try again. Share window. Okay. Do you see the screen now?
Not yet.
Okay, maybe I give up. And that's it.
Not
All right, sorry about that. Did you see anything?
No. So Doron, where you cut your mic, can you click on cutting your mic, reopen your mic on this location? Well, you don't need to do it, but next to this, there's a share screen button that you did use 3 times already before during the talk.
Oh, okay, maybe I cancel. Okay. Oh, right. I cancel everything. Okay. Oh, okay. So,
calling me, Doron?
Yes.
yeah, go ahead.
I'm here.
Report on the Dr. Mireille Bousquet-Melou's habitation script. Dr. Mireille Bousquet-Melou's areas of research is combinatorics and its application to physics and computer science. This is nowadays a very central topic, since it's become clear that the combinatorial methods are very effective in tackling difficult problems in statistical physics. In physics itself, the importance of the exact solved models is rapidly increasing, since by solving a model exactly, one can find all the relevant physical information without the need for approximation. Conversely, methods that started out in physics are now being used in combinatorics.
Thank you. Now let's skip a little bit. Let's skip a little bit here. Okay, so how about this paragraph? Bousquet-Melou.
Bousquet-Melou is very knowledgeable about her field and collaborates well both with mathematicians and physicists. Her recent work with the physicist Tony Gutmann is a very significant contribution to the physics literature. It was a true pleasure to read her habilitation report. The beautiful, lively style could only have been written by a truly outstanding genius who has a panoramic view of her field and who understands it in many levels and meta levels.
Thank you very much. Okay, thank you. That's enough. It's such an accept. Thanks so much, Oxy, for doing such a good job. So anyway, in the first, so I'm against anonymous referring in anonymous letter of recommendations. So whenever I write a recommendation letters, I send it to the subject. So I sent to Mireille, but the first version, I didn't use a spell checker, and I stupidly, I misspelled, I had a typo. So I spelled genius with U-I-U-S. So here is the report, the email she wrote to me. So let me, if you would have been here, I would have asked her to read it. So this is the email message she wrote to me. Dear Doron, you might have understood from different emails that I have had some problems with my habilitation defense, which has finally to be delayed. It will be on December, blah, 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 blah. But then she said, thanks for the letter. Also, should this genius that I misspelled it be changed into genius, spelled correctly? If yes, I'm blushing. So anyway, she got a little bit in trouble because you're not supposed to send your dissertation before the official chair sent it to you. So she broke the rules. She took a shortcut and she got a little bit in trouble, but they forgave her. So I was very proud and very impressed by Mireille Bousquet-Melou. She really, really did well. But then I had some setback. I had some disappointment with her. Yeah. So in 2006, I wrote a great masterpiece, really using symbolic dynamical programming, but I think it's one of my best papers. Basically, it's teaching the computer how to do mathematics and research all by itself. It's the same methodology I use later on in other contexts that I may have time to tell you later. But if not, this is a good example of dynamical, symbolic dynamical programming. So let me just give you briefly the paper. I have a dream, write a maple program that so one day the computer can do everything. You only give it in English or any language, this text, and using machine learning, it would do everything I did developing the Maple of Sage package. But this time did not come yet, even today. But once I wrote the Maple package that teaches the computer for a very, very general. So this is a bit like the partition analysis, where you have an algorithm, and once you have it, you can tackle many, many problems. So this was a case of a family of problems, tilings. The classical tiling problems is a famous dimer problems, for which Castellian and Fisher and Temperley famously did the closed form for an arbitrary rectangle. And the monomer dimer problem is still wide open. It's really, really difficult. But of course, it's still for any bounded rectangle, but still, it was really, really a beautiful paper that I recommend. And here I explained how to do it a human way, to explain the methodology for a 2x n case. And lo and behold, you get the Fibonacci thing. So that's it. And then you take the weighted numerator. So in this case, you get a very simple system, 2 equations, 2 unknowns. This a human can do. And even for larger case. But it was nice to see the computer to actually, from scratch, generate so all the phases. In the old days, a human took a specific problem, found the intricate combinatorics, or using the so-called transfer matrix method, found manually the set of states, and then manually using human ingenuity, found the transition matrix, and then at the end of the day, possibly use the computer. But here the computer does everything from scratch. It dynamically sets up a system of equations. So it starts with the initial state, and then you get what I call the children's state. And they, in turn, have their grandchildren and great-grandchildren. But guess what? Since it's bounded, sooner or later, there are no more new children. So you build dynamically, that's what I call dynamical programming, the tree and the implied set of equations. And the computer does all by itself. And then that's the weight and numerator. And a little bit like Andres talked before, it can also do with label things according with the weighted thing, and then do automatically statistical analysis for the correlation, the higher moments, and whatnot, completely automatically. There was a masterpiece I was so proud of. And I submitted it stupidly to a journal called Journal of Combinatorial Theory. And guess how upset I was when it's an old grief, but I'm still upset at yesterday.
Doron, sorry. Yes. Doron, can you switch on your webcam? Perhaps it is worth it.
I switch my... Oh, you don't
webcam.
See me?
Yes, if you can switch on your webcam.
Oh, but I'm afraid to stop sharing. I don't know how to do it.
It should not stop sharing. You have 4 buttons.
Oh, I minimize.
The first one is microphone.
Okay.
The second one is closing everything. The third one should be sharing webcams. and the first one should be sharing screen.
But only one problem, I don't see it because they stop sharing, obstructs it, and I'm really paranoid about losing the screen again. So what's the problem? You don't see me?
We don't see you, but you can go on. Okay.
I'm also good looking, so I don't think you lose much. Okay. Okay, thank you. Oops, and I lost the screen. Oh, I should have. Oops. Where? Sorry. Yeah, I'm not very good at it. You see the screen again?
We see it, yes. Yes, we see your screen.
Okay. Okay, sorry about that. I'm really afraid it will the screen. Okay. So it was rejected after 1 month. And I was so upset and was disappointed at so here's a note. Edit April 14th, 2006. This article was submitted to the journal CTA and was stupidly rejected by its managing editor, Hélène Barcelona. By the way, it's not managing editor. Her title is more prestigious, editor-in-chief at the time, which I don't think is deserving. And the members, so it's really great inflation. In the old days, the founders, the editor-in-chief were Giancarlo Rota for Series A and Tat for Series B. And then the managing editors were Bruce Rothschild and Basil Gordon, both eminent mathematicians. So then I don't think it was an appropriate title to call Angel. Never mind, this is not relevant. Anyway, so here was my rebuttal that the referee really didn't understand. I'm really disappointed. I don't know who it is. If you're in the audience, you're welcome to tell me, but you don't have to. Anyway, so you can read my rebuttal here. So the most thing, this very, very thing that does not seem to contain any original mathematics. So here is my reply. Mathematics my foot. Algorithms are mathematics too, and often more interesting and definitely more useful. Anyway, I was very, very upset. But so I still didn't get over it. And I boycott Journal of Quantum Theory that now became, part of it became electronic. But this is. But before going on, I'm a little bit afraid to sell to things, but let me see about the time. Let me just, never mind. You can go and download the tilingstxt program in my homepage and play with it because I have to move on. So more reasons was another disappointment by narrow-minded editors. This time, not referee. It's only the editorial decision. So I decided, because I get so upset when papers get rejected, unless it's a paper unless I have collaborators, to only submit it to the archive in my personal journal. And sometimes it gets accepted, but with annoying comments that so it's too much overhead. So, but in this case, it was solicited. The journal, as a biocomm, used to be a journal of biocontrolling, but using this very fashionable trend of becoming online and free access, it became algebraic combinatorics. So it's called the delete the journal transform. Journal of algebraic combinatorics became algebraic combinatorics. And it was a special issue in honor of my good friends, or ex-friends rather, Ian Goulden and David Jackson. And I thought that they were going to love it. The paper, once again, I wrote with Manuel, a really, really big paper using numeric dynamical programming, but also having a theoretical component. So I don't have time to tell you. You're welcome to look at it. It was really beautiful use of intriguing conjectures. And here it was gave rise to an opinion. Think twice before you submit your paper to pretentious journals like the open access, quote unquote, but closed-minded electronic journal Algebraic Combinatorics, since the expected gain is negative. Anyway, here was a rejection, very terse rejection slip. Not even referees. Dear Manuel Carros and Doron Zeilberger, an initial review of your submission, counting standard Young tableau with restriction to meet. Oh, sorry. Let me make it. With restricted runs indicates that it's not likely to meet the standards of depth and originality that algebraic combinatorics is seeking. So, as a favor to you, to not to have further delay through refereeing process, I am returning it to you. So it was just desk rejected by the editorial decision. They took one quick look at it, and I have a much more detailed talk about it in the Manuel Carros seminar that you can find in my homepage, the link to it. Anyway, it was a very, very big disappointment. So let me just tell you, it ended with intriguing conjectures about, as you know, Young tableau are equivalent to lattice paths in the region x1 big or equal to x2, big or equal to x3, etc. But so this was our paper, and let's do the PDF. So it's still open. So they believe that these conjectures are not interesting. They are not deep enough or original enough. I don't know what depth original. So this is such a simple. Oh, sorry, it's a different paper. Yeah, this paper with Manuel Carros. So it ends with 2, and it's still open, and I'm offering a donation to the OEIS to let me tell you the. Okay, so here are the 2 sequences. The number of standard Young tableau of shape n and n, 3 by n, standard Young tableau, in which you cannot have a run of length 1. So if you have, for example, in a row, you have 4, you cannot have 5 right after it. You cannot have 6. If you have 4, you have to have 5 after. So all the runs, or equivalently, if you walk from the origin to the point n and n, always staying in x big or equal to y bigger to z, in every direction, you cannot change direction right after one step. Very, very natural object. It was not in the OAS. And we crank out the first 200 terms. It's here. And then in Manuel Carros' much bigger computer, we got 1,000 terms. And then doing modular arithmetic, he cranked out modulo 5,000 terms. And if it is definite or recursive, it's a very, very, very high order. So it's probably not. But here's the challenge to the kernel method mafia to prove rigorously that it's not. And surprisingly, unlike the sequences that come up in the kernel method that are not recursive, for which the asymptotics is ugly, the so-called connective constant is not so, neither the exponent, the theta, is irrational. Here is beautiful asymptotics. So reminding you, for the unrestricted case, is 27 to the power n over n to the power 4. It follows from the Young-Frobenius or Hook-Length formula. So it says 8, beautiful, beautiful number. And for the other case, in which all the runs are even, all the runs are odd, it's also n to the power 4. And it's still wide open. And I think this conjecture is very deep and very original. Okay, I'm almost out of time, but was something good came out of this rejection. The phrase deep and original, so this rejection, deep and original, inspired another paper, with this time with only Shlosh Biechad. Some deep and original questions about the critical exponents of generalized ballot sequences. And now I was very happy that in this case, the kernel method of Mireille Bousquet-Melou and her gang and Aline and other people who work on it. So Michael Warner, are you here, Michael? You're babysitting for your baby, Albert. Michael, are you here? Well, he wrote the email that he might have to take care of. This
is a trick. We have to send you email, and then you are not upset. Okay.
Yeah.
So,
you go trying to get excuse. In
okay.
case of Michael, he had to babysit for his half year, 6 months old or whatever, a baby. Her name is Albert. So then it's
exactly
excuse.
Yes.
It's called excuse absence.
Okay.
Okay. And well, this is Michael Warner. He proved all the conjecture, and he wrote me an email message, and then he posted the beautiful article in the archive, proving all the conjectures, so Shlosh Biechad found numerical estimates for the so-called theta, the critical exponents. So I was very happy that Michael, using the heavy machinery of Mireille, Aline, et al., was able to reduce the problem of counting certain three-dimensional works, but with weird steps into the two-dimensional case, and proving that it's definitely not definite. But even more impressive, he found explicit expressions for the so-called critical exponents for the theta in terms of arctangent of something. And it's all in his paper. In fact, you can look at it. So it was very impressive. So in this case, I have to apologize. So the kernel method is good sometimes, but not for proving that something is definite. The guess and check method can do it routinely when you have a big enough computer and you ask Christoph or Manuel to help you with it. Completely elementary. But to prove that something is not pre-recursive, you still need human ingenuity. So there's still room for human ingenuity. But you also have to respect that lots of stuff can be done with computers. And where is the table? Oh, here's the beautiful tables, explicit expressions for in terms of arc, cos, and hyperbolic. I was very impressed, and it matched the conjectured numerics. But the conjectured numerics were not good enough. Maple is not good enough to conjecture this, unfortunately. So that was disappointing. Maybe if you know that it's arc cosine of blah, 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 a pi over, then you can, once you know it, but they'll be cheating. So Maple has to go a long way, and also the other software in identifying constants. Also computing it to many digits was also pretty challenging. So let me end with a conciliatory note. There's still room for human-generated mathematics. But humans should also respect and appreciate algorithmic mathematics. So this ends my talk. Thank you very much for a great conference. Thank you.
Thank you very much.
Doron, you can switch on the webcam.
Yeah,
that's what I was going to ask.
So.
Can you please turn on your webcam now that you're not sharing the screen anymore?
I know what happened. I clicked too many times on share screen.
Okay, so you're still
seeing
your...
country like China. You have to be patient.
You're coming back, I think. I think you're coming back.
Okay.
We see so far... yeah, okay, we see you. Perfect. Okay. Thank you, Doron. Thank you for this very nice and original talk.
And deep. Also deep. Okay. Thank you.
Sorry?
Also deep and original.
Deep and original. Indeed. And nice. So we have a question in the chat by Bishal Deb, who is asking if anyone has tried doing combinatorics on the Lean project, or Lean, I don't know how to pronounce.
Say there, which project?
The Lean project? Oh, L-E-A-N.
Oh, I'm not familiar with it. I don't know. Be nice if it did. Oh, yeah, I heard about it.
Bishal, can you...
Now, it should be. But as far as I know, no. No, it's good. Now I remember, yeah. I've heard about it. It's a very good project.
Okay. Are there any other questions? Oh, there is Xavier Viennot in the room.
Yeah.
Not really a question, but some more comments. I remember in FPSAC 91 in Bordeaux, if I well remember, you say, after Christian Catenthaler told me that was not the exact sentence, but you say, extreme ugliness can be beautiful. Do you remember?
Yes, thank you. Thank you for quoting.
Maybe your rejected paper was not really enough ugliness.
Yeah.
And it's amazing, this story between you and Mireille, because Mireille, she claims she has three fathers. She has in Combinatorics, she has Xavier. In asymptotic, she has Philippe Flageolet. And in physics, she has Tony Gutmann.
Yeah.
So in which category you are? You are an admirer. It's like a love story with up and down. And it's, I remember when I retired in 2012, about 10 years ago, you were in Bordeaux and you were speaking so much about praising Mireille, that Mireille told me, but I am not retiring, it's Xavier who is retiring.
But it was implicit. You made Mireille. So any praise to Mireille is implicitly a praise to you. And also her being elected to the French Academy is in large part due to you. So you should have killed it. And in my humble opinion, both you and Fuata should have been a long time ago in the Academy. So it's nice that nowadays it's okay to have these beautiful combinatorics and be respectable.
It's my best it is my best recompense because we are in a computer science laboratory in Labrie, Mireille and I, in the same combinatorics, computer science group, and to have the silver medal of CNRS in mathematics. So this is all the mathematicians in Bordeaux were surprised. That was the first silver medal in Bordeaux, but not in mathematics, in our Labrie computer science. So everybody was, so this is maybe the best to show now combinatorics is really admitted in mathematics. And I will finish with the thesis, Mireille thesis that you mentioned. Do you know that Schutzenberger was one of the referees? And Schutzenberger wanted to introduce what he calls the DSV methodology. DSV because to coding some object like planar maps with word of algebraic language, and then you have the equation, everything, and you want to have this methodology a name, and so he asked Mireille to rewrite the whole thesis, putting DSV methodology by coding word, and so she has a lot of work to do. And I said to Schutzenberger, no, you cannot do that. And Marco said, if she don't do, then it's I will not refer it. And I asked Marco Schutzenberger, what means DSV? So D is for Dick language, S for Schutzenberger, and V. He told me, just guess what it is. It's okay. So that's a good memory. Thank you for this remembering all this memory and all this story. Thank you, Doron, for your talk.
So are there other questions in the room or the chat? I'm a bit far away from the chat, so I should check. No, I think not yet. So maybe I had a question because you mentioned several results from the near or distant past, and so I want to ask also a general question for the future. So which are, in your opinion, the most important open problems that one could tackle using computational mathematics in the field of lattice space and related topics?
Oh, well, hopefully the self-avoiding walks, the big ones. And in general, P not equal to NP, and the Riemann hypothesis. Hopefully there'll be a computer generated, and possibly also the college conjecture. There'll be a computer generated proof, very, very long, similar to the four-color theorem. So only a computer can discover it, and only a computer can verify it, but in the high level, conceptually, will be 1-9. So this would be my dream, to find a 1-9 proof, but the line is a computer line, that you can understand the code, you understand, like a four-color theorem. It's really a trivial proof, modulo routine checking. So hopefully also the other big problems, the Riemann hypothesis, the P not equal to NP, and who knows, even the college conjecture. And in the case of lattice part, of course, self-avoiding works.
Okay, so yeah, we can all hope for that. So if there are no other questions,
yes? I may have. Okay, so a question for Doron and possibly even for George. What do you think, if you heard about it, of the Ramanujan machine? It's some type of automatic brute force approach to get a lot of identities in the style of Ramanujan. It rediscovered quite a lot of stuff which were obvious, some which were known, and a few of them, I believe, are not proven. I don't know if it is still the case. Perhaps they have been proven since. So do you know about it, and what do you think of this? Perhaps Doron first and then George?
Yeah, here we beg to differ. I think the actual results are not so interesting, but the methodology is interesting. It was nice. It made it more widely known using submitting to nature. And I was one of the referees. And I really have to learn with them in diplomacy. They sent it to 3 referees. One of them was myself, was a raving review. The other one was completely negative, and the third one was in between, sitting in the fence. And the rebuttal that they sent me, they were so polite. We'd like to thank the referee for his very insightful, the negative review, for very insightful comments, but we beg to differ. So we're so diplomatic. So after 3 iterations, in the end, it got accepted. And if I would have gotten this negative report, I would have written them an angry rebuttal saying, go to hell. So I can learn something. Anyway, I think it's a very, the thing itself is not so important, the actual result, but the methodology of using experimental math, even though it has been done before, but packaging this way and marketing it. Marketing is also very important. So it was a marketing also to the force of this. And George, as usual, begs to differ. Okay.
So I believe there was a popular article after the appearance of the Ramanujan machine in which I believe Doron was interviewed, and I certainly was interviewed. So I don't know that I would call myself really negative on what they actually achieved. I suppose I'm negative on calling it the Ramanujan machine, because it makes it sound like that we now have in the machine something that is now able to do the things Ramanujan did. And I think that we are very, very far from having machines be able to do that, but their actual mathematical achievement is significant, and I admire it.
thank you.
And do you know if there are still some formulas which are open?
I don't know, no.
Okay. I had a look some months ago, and I believe that some were still open. So it's challenging that the computer managed to
You're
find...
muted.
Doron. Okay,
Yeah, they keep producing new ones. So the website is active, it's dynamic. So they keep coming with new ones. So hopefully it can become really interesting.
So we need some type of RD checker which could cancel out of this stuff, the stuff which are easily provable by some known identities. No, but for sure, it's a part of marketing. I mean, to call it Ramanujan machine. I have to say that it was a good idea to call it Ramanujan machine because it's the best. Yeah, but some results are nice. Okay, so thanks, Joanne. I am done.
Okay, so thank you to all three of you. Are there other questions? This time I think there are none, so we can thank Doron again.
And thank the organizers.
Thank you very much.